Welcome back, guys, to the WTF garage, and as you can see, it's absolutely hammering it outside. It's good to be indoors in this rather cold garage than it is out there. Anyway, just a few more updates what we've done with the Spey. It's got a nice waspy yellow and black spinner, which I've repainted. I thought that looked quite cool. It's pity it doesn't actually turn. If it turned, I'd put one of those spiral things on it, but unfortunately it's fixed, so I think that looks pretty cool. Anyway, moving on. So I've done a bit of work on the throttle cables, and what I've had to do here is, that's the throttle cables down there, and we've got the high pressure cock and the throttle. So what I've done is I've mounted some aluminium plate here, and we've got our cables. These cables are about 10 meters long. We don't want to be too close to the engine. And the other thing I've got to do is mount the handles, just to show you where one of the handles is. I should say. That's the throttle handle, and we've got to mount this. These are quite stiff to move, so we've got to mount these on some solid pieces of metal, which I'm going to show you in a minute. So as I mentioned, these throttle cables, you know, you need something. They need to be mounted quite securely in order to move them. So what I've decided to do is use some large sections of box section steel, and eventually, when this is all constructed, it will probably sit on one of my Black & Decker Workmate type things, which we can take out and mount the control box on, as well as this throttle quadrant. I think it's probably the best word to describe it. The same terminology as they use in an aircraft. So I've got two bits of steel here, two bits of steel plate, and I've already drilled the holes in it. And the plan is to weld those on there, and weld another one on that side there. And we attached the throttle to one of them and the high pressure shut-off valve control lever to the other. And hopefully with this, we've got a nice, strong, heavy, sturdy base, because when you're pushing the throttles backwards and forwards, or the high pressure shut-off valve, you're going to need a strong, secure base to push against. So I'm going to weld all these up and give them a bit of a paint job, and then we'll move on to the next part. Right, after a quick coat of paint, we have a throttle quadrant which looks, in my opinion, remarkably similar to that found on a Nimrod. Not that I've even seen one. So we've got some sticky labels there, just to remind us to press the right lever. And 10 meters of cable going back to the engine. These cables do have to be pretty straight for them to work. If there's any sort of redundancy or slack, then you don't get the full range of movement at the engine. That's the throttle, and we've got the high pressure shut-off valve, which opens and closes the fuel. That one's a little bit more difficult to do with one hand. So that's that. A few more little minor jobs to do, and we'll carry on. One of the other problems we've got to deal with is the air delivery valve. Now what we have to do is to somehow attach a hose to this from an air starter or an APU so we can deliver the air required for starting. Now the only problem is we've got to put a non-return or check valve here, and that might be a bit of a problem because I don't have a check valve for this particular engine. So what I'm going to have to do is, well, what I've done I should say, is actually source one off eBay from the multitude of sellers that seem to sell old aircraft parts, and see if we can adapt some hosing or some ducting to clamp onto this pipe. So moving over here, what I've got, I actually have a non-return valve. So if you have a look at it, you see it can only go, yeah, it only goes one way. But it's not going to fit on there though. Too big. So I've been welding up some various adapter plates. Oop, that one's still a little bit warm. And here's another one as well. So the idea is that this is the larger one. The air hose will go on there. We'll probably put a silicone gasket or something. And then that'll go on there, something like that, and put some V-band clamps, and hopefully it should work out. Right, I'm going to finish off grinding that down, and then we will move on to the next phase. Okay, after a little bit of fabrication, there we have it. We've got our starting air delivery system all sorted. So I've built up there's a pipe there, and non-return valve or check valve is in here. Nice two solid V-band clamps, and there's also a gasket in there. And this duct here, that is where we will connect up the air delivery hose. The only problem is we're a bit short of space between here and here, so we might have to remove this, but this shouldn't be a problem. It's just a supporting arm on the rear support there, but that's pretty chunky and it's gone onto the transportation frame there, so if necessary we'll probably have to remove this frame. Anyway, the other job I've got to do is back to the control box. It's just really to test the control box and the multi-pin connectors and the control leads. So at the moment I've got everything plugged in. There's my little homebrew 400 Hz inverter, which we need for the oil pressure gauge to get that to work. And the other thing that we've got wired up as well, which I've got on the floor here, I don't know if you can see that, that's my little igniter box panel, which is transportational, so you can just lift that out. And that, when we eventually run this engine, will sit underneath the engine on the transportation frame. So everything's rigged up, and I just want to give you a sort of run through the starting procedure. It's be sort of like as it would be, except the engine's not going to be cranked and there's obviously no fuel connected. So we'll quickly show you that. So I've got my multi-pin connectors there, and we're going to be going round and connecting it up to the control box. Right, okay, so we've got everything wired up, and I'm going to just take you through the sort of sequence that we would do if we were planning to start it. So we'd obviously have the engine connected up to an APU via the air delivery hose, and the first thing we'd do is obviously put on the main DC bus, 24 volts, and as you can see there's no oil pressure and there's no fuel pressure, so those are what we would expect. We would then put the inverter on, and as you can see the oil pressure just gives a little kick there, but again it's not reading anything because we haven't got any pressure. Once the APU is up and running and it's stable, I would then signal to the APU operator to deliver air, and hopefully at that stage we would turn on the air valve, and we would also put the igniters on. You can hear. We also, at this point, we'd be keeping an eye on the N2 RPM and also the oil pressure, making sure that we've got oil pressure. We should start to see that go up slightly. Obviously, the engine is not ignited at this stage. So once the engine starts rotating on the starter, we should see this go up to somewhere between 10 and 20%. And at that stage, it's usually fast enough that we can let the fuel in, and hopefully we should get a light off. So once the RPM's up to about 10, as I said, 10 or 20%, open up the high pressure shut-off valve, and we watch the TGT gauge or the EGT gauge, and hopefully if we get a successful light off, we should see that rise. At this point, the engine is basically starting to accelerate with the help of the starter. And once we're happy that things are going in the right direction, again keeping an eye on the oil pressure gauge, the N1, because the N1 will start to increase as well, which is the low pressure shaft. Once we get up to about 40 to 50%, we can turn the igniters off. We should be able to switch the start air valve off, and at this stage we're again watching the RPM to see if the engine starts to stabilize at its idle speed, which would be about 50 to 60% N2, that is, and then it'd be slightly less on N1. Again, keeping an eye on the oil pressure. If, for instance, we had a problem that for instance, if there's excessive air delivered from the APU that causes the starter to overspeed, then there's a special cutout switch mechanism within the starter which would then indicate on here that the starter is cut out. You can actually leave it to run. It should be possible to leave the starter to run till it's at maximum speed, and it will cut out automatically, therefore shutting off the air delivery valve, and therefore preventing it from destroying itself. So that's more or less the starting sequence. And what we would do is then, in order to switch the engine off, we would simply then shut the fuel off by closing the high pressure shut-off valve to the fuel, and that cuts the fuel off. So I'm reasonably happy with this box, that everything does seem to be working, all the connectors seem to be going to the right places, and I think we're more or less at a stage that the engine, as far as what I can do, this engine is now ready to be run. Basically, we've got oil in the I've put oil in the oil tank. We've got fuel pipe connected up. Though we haven't got any fuel yet, that's something we'll have to organise. And we've got all the electronics are done, and it's just a question of waiting now until this lockdown finishes, which I don't know when that will be. We can get my friend Ian over, and then we'll be able to get his APU, connect it up, and then we'll be able to run the engine. There's one or two minor things I have to do outside just to make sure that the engine, once it's outside in the testing area, that we'll be able to make sure it doesn't sort of take off or anything. So a few ground struts that need to be put in to tie it down securely. So apart from that, it's more or less done and dusted. So until we can run it, which I don't know when that will be, possibly the spring, maybe sooner, we'll keep you updated. Thanks for watching.